Characteristics of edge computing. Hello and welcome to Edge University. I'm Jeffrey Ricker. In this lesson, we'll discuss the characteristics of edge computing. In so doing, we'll better understand the challenges of edge computing and how to address them. Edge is not a data center. Here are 6 characteristics of edge computing. There is no data closet. There's no technical staff on site, hundreds or thousands of locations, limited or intermittent network bandwidth, it's behind somebody else's firewall, and the demand for computing power always is increasing. For some of you, this will be validation. You're not alone. Many others face the same challenges. For others, such as IT professionals who have spent their career in the data center, this will be eye-opening. So let's dive into each of these 6 points. As mentioned earlier, industry is using the term edge rather loosely. Some call regional data centers near edge. HiveCell is focused on the far edge, or real edge computing. So the first characteristic of an edge computing environment is there is no data closet. Even if there is a data closet, it was full, underpowered, and overheating long ago. There's no room for more servers. The photo here is a typical edge deployment environment. It is the engine room of a cargo ship. You'll see pretty much the same thing on a factory floor, in a job trailer, in a quick service restaurant, on a retail store, warehouse, clinic, etc. In other words, the real edge. There's no uninterrupted power supplies, no top-of-rack router, sometimes there's not even air conditioning. This is not the sort of place that you put a $20,000 server. The second characteristic of edge, there is no technical staff. For the IT department working in the data center, this is hard to grasp. You see, they operate in a centralized control environment surrounded by their peers. They know how to shell into a server, configure a network router table. Doesn't everybody? No, they don't. And the most basic knowledge in a data center, the stuff that a summer intern should know, is rocket science to anyone else. So how things get done, get installed and deployed in a data center is just not going to work at the edge. The third characteristic of edge is there's hundreds or thousands of locations. Some customers have tens of thousands of locations. Now a DevOps guy, someone who manages deploying enterprise applications, he's used to handling a deployment location. There's a dev environment, then there's programmers use, there's a UAT and a stage environment for testing. There may even be regional production environments, but all total, you can count them on your hands. But edge is different. You may have thousands of stores or thousands of oil wells. And a simple manual process is feasible in the data center. It takes 5 minutes, no big deal. But with edge, however, that 5 minutes for 1,000 locations becomes 5,000 minutes. That's 83 hours. That's more than 10 working days. That's a big deal. It's the difference between pets and cattle. Traditional enterprise software has pet servers. You name your pets. You know when they ate, what they ate. Edge computing is a herd of cows. They don't have names, they have tags, and you feed them en masse. We'll discuss more about edge scale in another lesson. The fourth characteristic of edge computing, limited or intermittent network connectivity and bandwidth. In one deployment of HiveCells, the customer had a remote cluster connected to the internet through a satellite modem. Someone parked a piece of heavy equipment and blocked the line of sight to the satellite for 6 days. Retail stores do not have such an extreme situation, but local outages are a reality. Large storms or even construction accidents can knock out communications for hours or even days. Management systems for data centers do not anticipate limited or intermittent network connectivity. Some systems expect 20 gigabit connectivity between servers as a minimum. That's a ridiculous expectation for the edge. Data centers manage their systems through things like VMware Center, which makes simple assumptions. The management software is behind the same firewall as the servers it is managing. This assumption is perfectly logical for a data center. It can be made to work for virtual private clouds. However, it is completely illogical for the edge. These systems require dozens of ports to be open to connect to the server. Creating such large holes in a firewall is unacceptable. Creating, maintaining, and monitoring the required holes in hundreds or thousands of locations would be a huge undertaking. Read expensive. In reality, however, it is an impossible task because quite often in edge developments, you don't have control over the firewall. Someone else owns it. For instance, in franchise retail, the franchisor wants to deploy edge computing in each store, but the various franchisees own the network and the firewall in those stores. It's a completely different challenge. The last most notable characteristic is that demand for edge computing power at the current moment is relatively small. Once deployed, however, the demand will increase continuously. There will be another application and another and another. New unanticipated use cases will follow one after another. The data will grow and grow. There will be more smart devices, more machine learning models, more of everything. When planning edge computing, customers need to consider how they will incrementally increase their edge infrastructure. The cost of the initial deployment is just the beginning. Edge infrastructure will need to start small and scale quickly. Based on this edge environment requirements, customers have clear expectations for edge computing that are different from the cloud or the data center. No special equipment for power, air conditioning, or networking. No technicians necessary on site to install and configure. You need to start with the smallest footprint possible to demonstrate return on investment. You need to easily add more compute power as workloads grow. You need to be able to run distributed software for containers, messaging, and machine learning with high availability. You need to monitor, manage, and upgrade centrally even when it's behind a firewall you don't control. And you need to be able to apply continuous integration, continuous deployment for developers' operations. In other words, CI/CD for DevOps. In other words, what customers want is all the good stuff in the cloud just running on-premise, that is, at the edge, at thousands of locations. We must not forget, however, that edge is not the cloud. There are real physical limitations that prevent the edge from being exactly like the cloud. The biggest challenge, no pun intended, is the concept I call edge scale. Nevertheless, we can build solutions that meet the customer's expectations for edge computing. It will not be achieved by simply shoving data center solutions on premise. It will require new innovations. So that concludes this lesson. Thank you again, and look for more lessons at Edge University.